So the second grand idea of information technology, we talked about algorithms, and the second grand idea is abstraction. Abstraction is oftentimes misunderstood. Oftentimes in English, people use that term to try to convey the idea that something was confusing or cloudy. You know, oh, that's an abstract painting, or that was an abstract lecture. Actually, the word abstract means to simplify. Abstraction means just the opposite. Take something complex and make it simple. Well, as you just saw with algorithms, it's sometimes a little more than that, too. Abstraction means to simplify by agreement. You can't read the caption of the cartoon. The boss just tells her worker, I want this rewritten so even my husband can understand it. Okay? Need to simplify this somewhere. But it's not just making it simple, it's to simplify by agreement. And we'll see what that means. So that's part of it. Take something complex, make it simple. Non-IT example. If this were physics, we would hope that somebody could explain Einstein's general theory of relativity to us without us having to read his 1905 paper. Because trust me, trying to read Einstein himself is really difficult. It's hard. So we hope somebody could take this very complex idea and somehow simplify it such that we could understand it. Okay, you want to see Einstein simplified? You can laugh now. But actually, this paints a pretty good picture of abstraction. Now, you've never met Albert Einstein because he died before you were born, but if you've seen pictures of Al, this sort of looks like him. If I put this up there, you might be able to guess that that was Albert Einstein. And you'll notice with each successive panel, we have removed some detail, such that by the time we get all the way to the right side, if I asked you who, well, you would know what it is. You'd know that'd be a person. But big nose, facial hair, you might think it's me. This is abstraction. Abstraction is to strip away the detail such that we could focus on what's core or central. Abstraction is one of the most powerful tools that an information technologist has. And much of our job is figuring out how do I abstract this. We'll talk about the tools and techniques and how that's done. But much of our job is taking something complex, whether it's a problem or whether it's a piece of technology, and being able to focus on it simplistically. An example. Think about how many systems do collapsing trees. This is Windows Explorer, and you know that most modern file systems are done hierarchically. You've got folders within folders within folders, right? Well, I could show you every single file in my file system. That'd be too much, especially if you're looking for years. That's not how we do it. Because it's already been logically arranged hierarchically here in this folder within folder way, then what we can do here is we can just, all right, hey, you want to see the computers? Then you don't need to see the printers. You don't need to see any other piece of text. So we'll just focus on that. You want to see what's in that one particular computer? Then we'll focus on that. This hierarchical tree is a very common technique that IT professionals use to help users deal with the complexity of the system. Okay, you know what? Let's pretend we had a discussion about this. We should be discussing more rather than me just talking, but let's just pretend that we had that discussion, okay? Third grand idea of IT is automation. Of the first three, algorithms, abstraction, automation, this is probably the most straightforward one. You know what automation means. Automation refers to something that runs by itself. Now, of course, we'll probably up that definition just a little bit. While we could say runs by itself, it's probably more appropriate to say, using IT terms, it will process autonomously. The image that you see there is a home automation system where the user can input a number of set points, a number of commands, turn the lights on at 6 p.m. before I get home, turn the heat up, have the coffee pot going, or what have you. Okay? Exactly, a home automation system. An example of automation that if you haven't thought of, I'm going to make sure you've actually done this, are macros in any type of productivity suite. In Microsoft Office, you can create macros. I'll define for you what a macro is later, but a macro is a way to automate a set of commands. If your users are constantly doing repetitive tasks manually, that's a key to us that says we ought to automate this. That's our job, right? Anytime you have to do something manually, especially over and over again, let's automate that process. And that's a primary purpose of a macro. Macros in the Microsoft Office suite, like in any productivity suite or any kind of environment, allow you to automate a set of commands. Let's just make something up. Let's imagine that I have a user and she's always writing a specific letter. Let's say it's a request for a proposal or something. And there's a standard format for that. And she always has to double space an abstract and it's indented 3 inches further, and then the body of it's something to, she's always doing this work. Well, you can help that user by creating a macro that will automatically run a set of commands. It's a lot easier to say, run this macro and then apply all this formatting, rather than manually going through and doing that formatting. Right? So Word there refers to Microsoft Office Word, that specific app. But you see this in many different cases. And we'll investigate this. We're going to actually create 2 different macros in this class. If you've done it before, great. If you haven't, don't worry about it. That's where we're going to go through the process. Let me give you one example of automation, and then let's see if you can come up with other examples. Again, all my examples relate to cars. Is that okay? You've certainly heard of autonomous vehicles, self-driving cars. Many people associate Google with this. They're actually kind of late to the game, and they're not the biggest player by any means. But if you know anything, Google's had a fleet of autonomous vehicles, mainly Toyota Priuses. Maybe that's Prii. What's the plural of Prius? They've had a fleet of Toyota Priuses running around Silicon Valley, where I used to live, in Sunnyvale and Cupertino. And these cars drive themselves. They are autonomous. There's a human being in the car, but the human being isn't driving. The human being is doing what human beings often do: shave, put on makeup, watch TV, sleep while they're driving. But this is okay because the car does the driving. The state of Nevada is the first state in the union. They have issued permits for people to actually own and operate autonomous vehicles on the road. If I recall correctly, there's another state that has followed suit, but you couldn't do this without special dispensation in Wisconsin. Don't buy an autonomous car and expect to be driven around here in Wisconsin. Not yet. That's a massive example of automation, isn't it? Think about the level of algorithms necessary, and think about the massive amount of abstraction that went into both creating it and now certainly provides the user. Okay? Autonomous vehicle. Any other examples that you can think of, from something as tech as a macro to something as weird as a self-driving car? I'll take it seriously. I just don't want to stand up to write. I'll write it down. Sir.
One example of automation, use your car analogy, or your car
Mm-hmm.
again,
Mm-hmm.
is the computer systems in your car.
Yeah.
You know, they're all,
Mm-hmm.
you know, gas is not right. It
Yep.
takes adjustments.
Yep. Yeah, exactly. There are a number of specific computer systems inside cars. Let's think about something that's fairly standard on GM models, not so much so on Ford. I don't think I'd quite. A Twilight Sentinel, whatever they call it. There's a sensor. When it gets too dark, it turns on your lights for you. Okay? Yeah, exactly. Good example. Lots of things in cars. Other examples of automation in IT.
So we use the car example here.
Good, I like it.
So, you know, years ago, they have people putting the cars together.
Yes.
Now they have automation. They have
Yes.
robots.
Exactly.
Algorithms control these robots.
Yeah.
That
Yeah.
the car.
Uh-huh. Exactly. Yeah. Whereas the assembly line at one time was human beings putting panels on and welding, now there are robots. Robots. Putting on panels, doing welding. Yeah, great example. You don't have to, don't feel you have to think of a car one. It's okay. I like car ones.
Buy
Okay.
vacuum cleaners that
Ah,
turn on.
exactly.
Vacuum clean your house while you're out.
Exactly. The iRobot Corporation's Roomba is one example. The robotic vacuum cleaner. That's a great example. Yeah. Don't have to do the work. Turn it on. Vacuums your house for you. Cool.
I'll give you a real simple one that, I mean, it's car related again. But when you take your car to a car wash.
Yeah. Uh-huh.
That's,
Right.
You don't think that, you know, and you don't think that that's technology. But
Mm-hmm.
It is.
It is.
Technology. It's
Absolutely.
automation.
Sure.
Something's got to be controlled.
Right. Yeah. There's a sensor to tell when you pull in or where you are, and then different things happening at different times automatically. You betcha. Yep. Absolutely. Good one. Anything else? Examples of automation in IT. Keep going. Good.
Tasks, some of my work tasks, you know, certain times, certain backups run.
Okay. Great.
Backups
Yeah.
completes another task.
Uh-huh.
You know, a series of tasks.
Right. Sure.
along the way.
Yeah. Good. Great example. Many people in general talk about using scripts. And that script is typically an operating system set of commands, and it'll run at a certain time, right? Your process wakes up at 3 a.m. to do backup because there are no users on the system right then. So the traffic of the backup doesn't impact them, and plus files that they're working on right now are not partially backed up, etc. So yeah, having it, and when that completes, something else happens. Good. Those are great examples. Anything else? Automation in IT.
So, kind of to that, you know, I used to work in a department that we do software distribution to thousands of PCs.
Yeah.
It used to be that you have to put in your disk.
Yeah, sure.
To install applications. But
Uh-huh.
now, you know, again, for example, using scripting and software, it's
Uh-huh.
automatically distribute and upgrade
Yeah.
software on hundreds and thousands of PCs.
Yeah.
That's what I use.
Okay. Okay, you miss it, I bet.
No.
Oh. Exactly. I mean, in the Windows environment, the WSUS, cloning machines using some kind of tool to automatically push out a, quote, image that's been updated to machines. Yeah. Keep going. It's
Well,
good.
on that, actually, I just put in a system, System Center.
Okay, yes.
Microsoft product.
Yes.
Which is a collection of databases and scripts and all
Yeah.
that stuff where you break everything down into small components.
Uh-huh.
Drivers,
Mm-hmm.
operating system,
Mm-hmm.
applications, break
Mm-hmm.
it apart, and the user can select what they want and what piece.
Mm-hmm.
Run a command, and then it follows
Pulls those.
tasks.
Yeah, to put that all together, to combine it and push it. Yeah. Probably that's great because it probably also includes abstraction. You know, not everybody needs the full and complete distro of whatever. And of course, different machines would require different drivers because of different hardware. So getting that, yeah, good example. Good example. Automation pushed our button. That was good. You know, that's usually one that people think about because, frankly, that should be one of our goals. Anytime things happen manually, there's the chance for error, right? If you have to manually, and I mean, I shouldn't tell you how often that may happen in a place like this, where something comes out of one system, and then somebody has to manually transcribe that into another system. Dumb, right? Anytime you need to do manual, then you introduce the chance for error. Okay, automation ought to be a good thing. Oops, well, that happened quickly. Okay, the other ones are as important, but all I want to do is I want to tell them to you, give you a little bit of a definition of them, and we'll see them more often. In this first unit, we're going to focus on the first three, but there are more. So the next triad, the next three, information, interface, intelligence. Information probably makes sense. I mean, this is information technology. Okay, let me just give you a straightforward description of these things. We're going to begin by defining information as useful process data. Information is useful process data. In other words, it's something that a human being can utilize to make a decision. There are two terms that oftentimes people in general use kind of interchangeably, and that's data and information. But in IT, those are actually different concepts. Data is the raw fact input to the system. Information is the transformed data. It's the useful process data. See, if your boss wants to figure out, sales trends or whatever, just looking at a mountain of data isn't going to be helpful. We want the system to take this mountain of data and transform it into some trends, some information that will help us solve the problem. Okay? Useful process data used to make a decision. Interface. My definition is a made-up word. I mean, go-between isn't a real word. Medium. Yeah, medium is a better word. Absolutely, but sometimes that's not very understandable, so I like to make up words anyway. But medium is a better word. Go-between just means something that stands between two other parties, facilitating communication and control. Classic example in IT is the user interface. The user interface is the combination of hardware and software that sits between us and the rest of the system. It's how we're going to enter data and issue commands, and it's how we're going to receive information and messages. If you're wondering about the little image there, that's brain synaptic interface. So the two folks are just thinking, and their thoughts are transcribed, and there it is, put it on the screen. You're saying it's in German? Yeah, that's because they're German. Interface. Go between facilitating communication and control. Sixth grand idea, the idea of intelligence. This is a hard one to define. We're going to wrestle with it. We're going to wrestle with it a lot in the fourth unit of this class, and if you're really interested, we have a course in the curriculum called Artificial Intelligence. Intelligence, and you caught it in that one lonely quote I gave you from Brookshire, right? Using intelligence, capturing intelligence via algorithms. I'm not going to define it for you today. Okay? Instead, I'm going to show you a Dilbert. The problem is in the part of your brain that handles intelligence. I can reboot you, but I won't lie. It's going to hurt. We need to talk. Okay, how not to be the IT department, right? The problem lies in the part of your brain that has intelligence. I think if I asked you, do you kind of know what intelligence is? I think most people would say yes. Unfortunately, when it comes to truly defining it, we're going to find that's a little hard to do. But we'll wrestle with it. So let's just leave it today. We kind of know it when we see it. We're all intelligent. We got the idea. Good enough. Now, final 3 grand ideas, just to round them out. Cognition, complexity, creation. Cognition, complexity, creation. Before we look at these, let me tell you, there's nothing magic about the order of them. It's not that algorithms are the most important and creation is the least important. And actually, we could use different terms for these things. As a matter of fact, the term cognition means understanding. So you ask, why didn't I use the word understanding? It's because I'm looking at alliteration here. I had 3 A's, 3 I's, and now 3 C's. Okay? There's nothing magical about the order of them, or even to a great degree the specific terms, although these terms have a specific meaning in IT. So let's look at these. Cognition, I already told you, means understanding. Okay? Oops. So rather than trying to get more in depth, let's just leave it at that. Cognition refers to understanding. In the world of IT, it might be understanding the problem at hand. It might be understanding the plan. It might be understanding the current system. It might be understanding the pieces of the new system. Lots of cognition is necessary in order to carry out IT. And then there's the whole question about systems themselves being cognizant, understanding. And absolutely, to a certain degree, they are. We talked about automation. Are self-driving cars cognizant of their environment? I sure as heck hope so. Do they know the difference between a double yellow line and a dashed white line? Do they know the difference between a shadow and a rock? I sure hope so. Right? Otherwise, it's going to be a very short trip in your self-driving car. Yeah. Cognition, understanding. Complexity. Yeah. Complexity sometimes catches people because everybody can say, yeah, something's complex has many parts, many pieces to it. But that's not all. To be complex, there have to be many interrelated parts. Okay. This is photoshopped. Even in Southern California, where I grew up, there's no freeway interchange like that. Okay? Many interrelated parts. It's not just that I have 1,000 pieces. It's that those 1,000 pieces have to interrelate to each other in a very specific way. That makes things complex. In IT, we refer to systems as a state machine. IT, technology is complex because the same piece of tech can exist in many different states, sometimes simultaneously. Okay? You know what's frustrating about technology? Use a piece of technology one day, everything's fine. Use the same piece of technology, and you believe the same way the next day, and it hangs, locks, freezes, jumps out of your hand, whatever, right? Why is that? Because it was in a different state. There are so many interrelated pieces. That's what makes technology complex, the idea of a state machine. The final grand idea, creation. I think if I asked you to define it, I think most people would be able to get to something like this. Creation, bringing something new into existence. Now, here's where graduate education gets difficult. For undergrads, I try to be very careful and use very different terms. We don't do that in the real world. We'll oftentimes use the same term in two different ways in two different contexts. For example, I told you that computer scientists are more concerned with creating systems and IT professionals are more concerned about applying and managing. But in a sense, don't IT professionals create also? They absolutely do. Just because I'm sorry to keep doing Oracle. Just because I'm starting with database management system X doesn't mean I'm not bringing something new into existence. It's true I didn't bring the platform into existence, but I brought this instance of it. I specified the schema. I specified the views. I specified all this stuff. So in a sense, aren't we creating? Yeah, we are. Okay, all right. Now people are saying, wait, I'm confused. Well, just work with it. What I'm saying is this. Our primary task in IT is not to create brand new from scratch. Maybe this is not a good example, but maybe it's the difference between baking from scratch and pulling out the package of whatever, right? See, if you bake from scratch, you take great pride in sifting your own. You probably harvest your own wheat, beat it into flour, sift it yourself, do all that kind of stuff, right? But other folks just buy that big package from Pillsbury where it's got a little packet of this and a little packet of that and a third packet of that, and the instructions say now combine it all together. Well, a real chef would turn up his nose and say, but for me, I created that. Okay, I poured all the things into the container, stirred them all up, put it in the oven, and baked it, right? Yeah, okay, that's okay too. So an IT professional is often creating something new, but we're creating using somebody else's foundation. I didn't harvest the wheat. I didn't sift it, right? Yes, I bought a package mix, but that's okay. It didn't mix itself. I did it. No more. Just work with it. Folks, if you don't mind, please don't be the bear. Oh, you can't see. Darn, I don't know. At the beginning of every semester, I have students make sure the technology is all set up, and they said it's all set up, and as you can see, it's clipped at the bottom. It's on that way on the plasmas too, right? Darn. The bear says, how about no? Okay? But let's not be the bear. Let's actually do this. If you don't mind, I'd like to find out who you are. See, I got this list, but that's really uninteresting. So we'll just go around the room, and if you just tell me your name. By the way, if you have a nickname that you'd like to go by or another name, tell me your full name first of all so I can find you on the list, and then if you want to go by something else, tell me. And then just one thing. I don't care what. Maybe, you know, what you do right now. Are you working? Are you a full-time student? Or just one interesting fact about yourself. Okay? All right. Sir. Okay? Okay. Thank you. Tell me, oh man. You know what would be helpful to me too? sometimes, do you know your CUWID number? I'm sorry, that's something you're going to need to that's something you're going to need to memorize. And I discovered in a previous class that somehow this can't be in the real system, but I had to use something funny when I was printing out my list here, and somehow the ID numbers got kind of offset a little bit. Ouch.
So let me just, do you need to tell me your full ID number or just the last three digits? I just want to make sure it's correct. Oh, it wasn't. See? See, right, that's good. But I still don't trust it, so maybe I'll ask you. Go ahead. Yep. Got it. Cool. Okay. When did you get this? Yeah, yeah, you will have to. You will have to. Share some technology that we use, or some technology that you use. Just shout out to whatever you think's a piece of technology. Tell me a piece of tech that you use. Sure. either personally on the job or in your business? Absolutely.
Absolutely. Your phone is certainly a piece of technology. Probably a lot of folks have a phone that does more than just calls mom. Yep, got it. Okay, good. Others? Tech.
Laptop.
Laptop? You bet. I know what you're thinking. You're thinking, well, it's too darn obvious. I mean, yeah, I know. I was going to make a point. Maybe I won't. Yeah, we don't need to do that. Okay. What I want to do is I want to take a break now because I will get into some other things in a little bit, but I don't want to start them just yet. So it's a tiny bit early, but we could probably stand it anyway. So